a fuel burn example now. We're depart overloaded with respect to our winter displacement, a winter mark by 330 tonnes, and we're going to use these values per day. And we're given a speed and with a boundary of 32 degrees south as the limiting latitude between summer and winter zone. So in effect we can't go beyond the summer zone until we've used up the 330 tonnes. First calculation, what distance do we need to steam to bring the vessel to the winter displacement? So that's fairly straightforward. Divide the value 330 by the daily consumption, convert it to hours, multiply that by the speed, and that's the distance you have to go. Now we're going from 23 south, 70 west to 27 south, 153 east. So we're going along this route here, and we have a limiting latitude. Okay, so what we do to solve this problem, the first thing we do always is use Napier's to calculate the shortest distance to the limiting latitude. So I've put my values down here, and I've worked out that the shortest distance comes out to 2,549.7 miles. This distance is less than the required distance to steam to be at the winter marks. So we retain this distance and cover the remaining 3410 minus 2549.7 by parallel sailing along the 32 degrees latitude. Now the 3410 of course came from the fuel burn distance. So just putting it on the sketch here, we've set off from this distance, we've gone by Napier's, and it's taken us 2549.7 miles. So now we're going to steam the balance of fuel burn along a parallel sailing route. So that's step 1, then step 2. So the distance to cover by parallel sailing will be 860.3, as we've just seen there. What we now need to do is calculate the d long between our initial position and the longitude when we reach the limiting latitude, and the d long from the parallel sailing. So in other words, we have to calculate this value here, this d long, and this d long here, these two values. We know PA, we know PV1, PV2. We can solve this value here by Napier's, and we can solve this value by the parallel sailing formula. So let's put it through Napier's, the first, number 1, this one here, the d long between our initial position and the longitude when we reach the latitude. It was here. Departure d long cos mid lat, so that's the second value. So we've got these two values, 47, 12.7, 1654.4. Difference between our two longitudes, and it gives us a remaining longitude of 72 degrees 52.9. So we've added these two together, subtracted from the total d long, and got 7252.9. So this value here is 7252.9. So what we do now, of course, we can work out the last distance by great circle as the vessels know at the correct mark, so it's no problem going into the winter zone. So we can do a great circle. So cosine V2b from there to there. We know P, we've just found it, the d long, and of course we know the latitudes. And we work out that distance is 3745.1. And I put them all three on the sketch there. So part A was Napier's, part B was the difference between Napier's and the fuel burn, and part C was a great circle. So that's Napier's, parallel sailing, great circle sailing. And that's what the way you solve it if the Napier's distance is less than the fuel burn distance.